becomes less effective. Let it go too far and it can actually damage your engine rather than protect it. This tasty Golf R32 is due an oil change, having done 10,000 miles since its last one. I'm taking a sample of its oil to the high-tech oil research laboratory of Intertech. By studying it at a molecular level, we'll see exactly what happens to oil as it gets older. I'll also test to find out if old oil makes your car slower. But first, laboratory manager Rob Chapman talks me through the sample. Rob, here I've got a brand new oil sample and also one that's done 10,000 miles. But the difference, just in colour alone, is phenomenal.
So that would be due to oxidation of the oil and also small particles of wear from inside an engine.
What would happen if I left this oil in the engine for, I don't know, 50,000, 100,000 miles without changing it?
Potentially, the small particles of wear would travel around the system and cause secondary damage, and eventually could lead to the failure of an engine.
As well as getting darker, oil's viscosity decreases as it ages and it becomes less effective as a lubricant. Our first test passes the sample through a glass capillary at 100 degrees Celsius. The faster it moves, the less viscous it is.
The result of the viscosity test comes out 12.7 millimetres squared per second. Compared against clean oil, which was 14.2, is showing a drop of about 15% or so.
That means the oil is 15% less effective at lubricating the engine, resulting in more friction, wear and heat. Part of that drop is due to fuel seeping into the combustion chamber and thinning the oil. Our oil is actually 2.5% petrol. Contaminants too. Over time, microscopic metal fragments break from the engine and are contained within the oil. To find out what our sample contains, Rob uses inductively coupled plasma atomic emission spectroscopy. This heats the oil to 10,000 degrees Celsius, causing it to atomize and emit light. Can I look in here? Am I seeing things like exploding?
No.
The colour of the light indicates which elements are present.
So the analysis shown us that we've got copper 54 ppm,
Parts per million. Yep.
And there's a bit of iron there, 22 ppm. So they're the two elements that shouldn't be there in clean oil that are present in the used oil.
Wow. The fragments measure less than 100th of a millimetre, but they can still cause friction, unwanted heat and wear. To reveal bigger, more damaging particles, we use an electron microscope.
So there can be bits of metal, could be bits of rust, or even looks like there's a bug maybe in there as well.
It does look like...
Have a look.
That's incredible. My sample is typical of what your engine will contain when it's due an oil change, so I want to find out if it's already blunting performance.